Welcome to Climate Faster, Smarter Climate Mitigation with Python. You're in the right place if you are interested in learning how the Python skills that you or your team have can be put to use to help us take action in the climate crisis. I'm going to cover an explanation of how some of the largest institutions think about the climate challenge and how we take action, how you can influence those decisions and the timelines on which all of our action happens, and end by giving an example of how the team at BlocPower was able to get into those decisions, accelerate them, and have a real impact on the climate crisis as an inspiration. So without further ado, this is climate mitigation. It's broken down into sectors. The UN, the United Nations, broke it down into these 6 sectors, some of which have overlapping components. Sectors are transportation, the built environment, energy, industry, agriculture, and nature preservation. These are wide-ranging verticals used to give us a way to group similar types of strategies, similar types of channels through which our action can be focused. And action in each of these sectors is going to look very different. However, there are some commonalities, and that's the mental model that I want to describe to you today. Each sector shares a common dynamic. There are investors and there are projects. Regardless of what those projects actually look like, the investors are always choosing which projects they want to focus on. And
Jordan, I'm sorry for interrupting. You're not sharing your screen right now. I know that you
I'm so sorry.
No, that's okay. I just wanted to make sure you had that.
Yeah. There we go. These are the 6 sectors. Pretty straightforward. I appreciate Pam letting me know that before I got too far into things. And investors and projects. Investors might be banks or NGOs, governments, large corporations, and importantly, individual citizen consumers. We all make choices about how we want to spend our resources, how we want to invest our time, and where we're going to help. Projects are basically where things are going to, what is being funded and where the funding might be invested. These can look different sector by sector. For some examples, in transportation, we might look at electric vehicles, whether or not to adopt mass transit. In the built environment, you have new construction and retrofits. You have regulating bodies being able to set standards, and you have governments and utilities offering incentives. In energy, which is electricity, generation, you have the choices of sources. You have your distribution strategy. And you have methods of and the resilience of the grid. Industry, agriculture, nature preservation, all the sectors have their own type of project where action is actually taken and what decarbonization looks like in each sector. But again, this is still and always thought of by the investors in terms of what impact, at what cost, and over what time. So for example, you might be asking where to put EV charging stations. If you are an installer, or you are a city trying to subsidize these, or you are a company building a private network, you want to think about where to put your stations, where they would be most profitable, where they would be most useful to people, and probably how long it would take you to actually build those things. If you are an NGO, you might be looking at how much you can pay a given farmer to preserve a hectare of forest. And in the building decarbonization industry, you have building owners who are choosing whether or not to invest in electrifying their homes or their buildings, when to do that, what technologies to use. So this is a common pattern where you have somebody, some institution or an individual choosing which project they want to invest their time into. And this pattern repeats itself in all of the sectors. Where Python can come into the equation is in interacting with how those investors make those decisions, because the investors need to know how to invest. Uncertainty is a significant factor that limits everyone's ability to invest. Financially, we're talking about a discount rate, which is a way of quantifying how sure or unsure you are, and minimizing or increasing the value of the money that you're putting into a specific project because of that uncertainty. In short, if you're not sure about how impactful it's going to be, you have to limit how much you can invest in that particular project. So the vehicle through which we, using Python, can interact with that investment decision and hopefully speed it up and increase it is by using Python's latent and inherent talent for data science to create and to defend answers. We can drive investment this way by basically answering the question of which projects should I invest in? And Python is really good at providing those kinds of answers and being able to quantify how certain we are and being able to remove that uncertainty or that ambiguity that would otherwise limit the scale at which an investment can be made or take a lot more time for the investor to get to that level of certainty, both of which are costly in terms of undermining our ability to act on the climate. So far we've talked about how climate mitigation is viewed by some of the largest institutions in terms of sectors that each have investors and projects. We started to talk about how data science through Python can, in theory, help facilitate investment decisions, i.e. actually put money into people's pockets where it's useful, where it can have that impact, by providing answers, modeling the situation, and suggesting a clear answer for which projects those investors should lean into, and allowing them to lean on Python's community and know-how and tools to confidently open the floodgates of more investment. I want to give you a specific example here. We're looking now at a screenshot of BlocMaps. BlocMaps is the product from BlocPower that our team built to help lower the barriers of designing incentive programs at the city and utility scale for those organizations, cities, utilities. I'm just going to probably refer to cities from here on out, for them to design the incentive policies that actually allow public money to be put into people's hands so they can choose to retrofit their building, they can electrify their building, they can make it efficient. And this is a very detailed process, detail-driven, detail-oriented. It takes technocratic skill and time to design these kinds of policies, to get approval for the budget. And that time is time that people can't take that action, that they're stuck in carbon burning buildings or inefficient buildings with carbon burning appliances, or inefficient buildings, and are detracting from our ability to act on climate. BlocPower, with about a half dozen people, created this product, BlocMaps, that has unlocked millions of dollars of climate investment, making that money available as incentives that get put into building owners' hands, especially in low and median income communities, to decarbonize those buildings. It makes the job of the sustainability manager, the person who's actually supposed to design that policy, easier so they can finish it in less time. It essentially helps them design that scenario. Here's how you most efficiently tailor who is able to get which money. And we base this on a data set of every building and the retrofits that we think it needs and what we think those cost in the local market, which incentives exist, and how likely the building owners are or not to make that purchase. We know the gap in kind of their budget. So this helps us spit out a scenario that might shave years off of the timeline for a city to decarbonize and more rapidly organize their community and their public policy and other stakeholders to rally around what we can say verifiably or at least confidently because of the data science that's gone into the back of this, that this is going to have these kinds of impacts. Here's exactly how this money is going to be put to use, who it's going to help, how it's going to help, how long it should take. And getting that money out the door sooner means we can actually start doing the work sooner. So this is how BlocPower has modeled the investment project decisions that are happening at the city level by saying, here are all of your buildings and here is how you can best support decarbonization of your city using data science driven on Python. And I'm going to now step forward through a couple of snippets where I want to talk about some specific types of problems that our team worked on and put to use in exactly this product. So one of these is the knapsack problem. In this context, we are designing an incentive program. This is literally the scenario planning that's done in BlocMaps, and you want it to be maximally efficient for its impact. It's for a city. The city wanted to cut its emissions by 50%, and they want to optimize for least cost. Going into this, in advance, our team goes and gathers raw building attributes, things that you would get from tax assessor parcel information, like the year that the building was built, some basic information about the structure, what it's made of. We also go and build a catalog of the types of equipment that are in use, so we know how efficient all the existing equipment is and the potential equipment we would put in. And we know the cost and greenhouse gas emission profile of kilowatts available to these buildings. So basically, we know if you retrofit it, how much it would actually reduce emissions. Missing one thing here, which we'll get into on the next slide. Let's assume we know what's called the energy use intensity of one of these buildings. If you know that, you have the complete picture, and that complete picture of what these buildings behave as. There's an optimization, it's that knapsack problem. Here's an algorithm for it. And this would, in theory, spit out a maximally efficient scenario for decarbonizing a city. Put into use here, you can see that it creates two scores. We did this, the knapsack problem, you go through, let's see, you calculate the reduction and the cost, you apply that knapsack algorithm and are able to then pretty swiftly, and this is really efficient, spit out the maximum cost, the total cost that the program and all the construction is going to take. This is your budget that if you are the city planner, you need to request, and the impact, total emissions that we're cutting. So you're able to say with backup confidence, this is the program we want to run, here's the impact of it. And in order to put this in motion, we need this money. This is months, if not years, of debate and lobbying and committee meetings from the legislature or the executive branch in a city that are avoided because you have the answers. You don't need to be lobbied and nudged and supposed and stress tested. Just it's there. It's time to go to work. let's dial back to that energy use intensity. That's a really key part. Another snippet that we can talk about is how to get that. We partnered with, at BlocPower, we partnered with Oak Ridge National Lab. This is a very well known in the energy space national laboratory. They have a model based on a lot of work that predicts the energy use intensity for a given building. It used to be by building archetype. We partner with them. We've had to retune that model. We are able to get it so it runs on every individual building. And the problem that we had to deal with here is that the snippet deals with is it's really hard to identify specific structures in distinct data sets. So we are matching rather than by address, which is just a string and has different formats and is not really well normalized. Addresses are really hard to deal with. So what we did is we made a vectorized similarity score based on the number of stories and the square footage of buildings in a very specific area. And this allowed us to bridge the gap between our existing data and the data that was output by the Oak Ridge National Lab model. As you can see, there's a line of good fit and there's a lot of noise. So what we actually then did is shaved off everything that was beyond the margin of error. And we used that to train a model so that now when a building needed to be matched, we could actually either directly match it to its output, its energy use intensity, or model what that should be if our matching algorithm didn't have that fuzziness. We put those together, and now you have the energy use intensity that rolls up into all the other building attributes, and that's the stuff that's used that we talked about in the earlier slides to kind of predict the output of your incentive program. None of these are wildly complex bits. They're not rocket science, but they're very smartly considered and put together. This is all, Python, NumPy, pandas, data frames, typical stuff that you probably already know how to deal with. And the question is, I guess there's two questions. One, how do you do this at nation scale, which we had to deal with? And two, where else can you apply this kind of pattern to help influence these investor project decisions? For the first part, this is the architecture that we use to compute our data modeling at scale. So we actually are doing this model on every building in the country, 125 million structures in thousands of municipalities. And the point isn't to get into the details of exactly how you do this type of infrastructure, only to say that it is solvable using a lot of off-the-shelf tools. And if you're interested in the nitty-gritty details, there's been really good talks so far that you should definitely go grab the on-demand recording of, or reach out, talk to us. We're working on open sourcing the Terraform scripts for a platform like this, but this gives you an idea of how we bring data in from raw sources, how we store it in a lake, how we make it queryable, how we shape it, how we get to the point that we can have building attributes and energy use intensity and do that joining so that when we build our application, it has a pre-worked data set to actually spit those outputs out to the user so that they can take their PowerPoint to their treasury and say, here's what I want to do with our $5 million budget for our decarbonization program. Here's the impact. Let's sign off on it and get it ready to go. And that's the whole idea. There's a lot that we can do with today's technology, and getting it deployed really depends on helping those investors choose which projects to pursue. That's the gate. And you, knowing Python or having a team that does, can scale your impact by identifying the investors and the projects in your sector, and then building tools that simplify those investors' project selection. You don't need to be a massive team or have tremendous resources. BlocPower is a very small team when it introduced BlocMaps. And every sector of climate mitigation has this kind of opportunity. There are similar decisions being made. There's always a decision maker whose job is to make the right policy, whether that's a legal policy or an investment policy. And they have the same challenge of making those decisions and setting those policies that are efficient, equitable, and just. They're just looking for somebody to help make those answers easily known. And that's where you're really well positioned with Python to make those things happen. So what outcomes can you or your team unblock using Python and data science to offer that help? How many other sectors have one hand tied behind their back because no one has made it easy for them to model the climate and social impact of their decisions? And where is there an opportunity for you to help bring about the age of adoption of these technologies and really lean into action and mitigation around the climate crisis? Thank you.